According to President Roosevelt, it was "a day that will live in infamy." On that early Hawaiian morning in December 1941, numerous ships were lined up on Battleship Row in Pearl Harbor. At approximately 7:55 a.m. on December 7, 1941, 360 Japanese planes dove through the clouds over Pearl Harbor. One wave came from the east side of the island and the other from the west. When the sirens went off, the still sleeping soldiers thought it was a drill. The Japanese bombed everything in their path. All of the battleships and aircrafts were still in line when it happened. At 8:10 a.m., 15 minutes after the first bomb, the USS Arizona's ammunition magazine took a direct hit. About 1 million pounds of gunpowder exploded, killing 1,177 crewmen on board at the time. Within 9 minutes, the USS Arizona sank. The battleships West Virginia and Oklahoma were also hit and sunk. In total, over a period of 1 hour and 50 minutes, 8 battleships, 3 cruisers, 4 destroyers, and many smaller vessels either sunk or were damaged beyond repair. On December 8, 1941, one day after the attack on Pearl Harbor, President Roosevelt and Congress declared war on Japan. Until then, the U.S. had remained neutral in World War II. Japan's unprovoked active war on the United States in 1941 ultimately culminated in this nuclear response by the American government in 1945. Shortly before World War II began, Albert Einstein wrote a letter to President Roosevelt describing German scientists Hahn and Strassmann's discovery of nuclear fission of uranium and the potential for Germany to build an atomic bomb. Hahn and Strassmann discovered the ability to split a uranium atom by bombarding it with neutrons. Some of the mass released by splitting the atoms was converted to energy. Following this, other scientists discovered that when the uranium atoms split, they release extra neutrons which could then split other uranium atoms, creating a chain reaction. American scientists began to investigate atomic energy potential. When the United States entered World War II, the importance of atomic research was elevated by the U.S. government. In 1941, the U.S. Army took control of the research and began the Manhattan Project, designed to develop the first atomic bomb. Over $2 billion was spent by the U.S. government over the course of the project, and it employed 130,000 people. The project was led by physicist Robert Oppenheimer. Other than the core group of scientists, none of the employees knew what they were truly working on. At the outset of the Manhattan Project, a uranium enrichment plant was built in Oak Ridge, Tennessee. Scientists at the Columbia University developed an extraction system to separate uranium metal from uranium ore, and a Berkeley scientist devised a process by which the useful U-235 isotope was separated from the useless U-238 isotope. The first atomic bomb, Little Boy, used a gun-type device in which a uranium projectile was fired at a uranium target, thus creating a chain reaction. Little Boy was 10 feet long and weighed 9,700 pounds. It contained a 55-pound uranium projectile and an 85-pound uranium target. The resulting explosion was equivalent to 15,000 tons of TNT. In contrast to Little Boy, Fat Man was a plutonium bomb. In 1941, an American chemist named Glenn Seaborg created plutonium from uranium-238 by bombarding it with deuterons. A secret complex was built in Hanford, Washington to make enriched plutonium-239 for the bomb. Fat Man contained a softball-sized plutonium core surrounded by 5,300 pounds of high explosives. Its explosive force was equivalent to 21,000 tons of TNT. By the summer of 1945, the first atomic bomb was ready for testing at a nuclear plant in Los Alamos, New Mexico. On July 6, 1945, Robert Oppenheimer ushered in the atomic age when the Trinity nuclear bomb, nicknamed the Gadget, was detonated in Los Alamos, New Mexico. Following an intense flash of light, the explosion extended upward 40,000 feet. The force of the explosion was equivalent to that of 20,000 tons of TNT. It vaporized the steel tower it sat upon and heated 800 yards of surrounding desert sand into glass. As World War II dragged on, and Allied as well as Axis forces continued to perish, the Allied forces leaders searched for a way to prevent further loss of lives. When the United States decided there was no other option for ending World War II, the U.S. B-29 bomber, the Enola Gay, dropped the world's first atomic bomb on Hiroshima. Its target was a large Japanese military installation, but the bomb also vaporized over 80,000 Japanese citizens and decimated the city. The devastation was worst within a 2-mile radius of Ground Zero. Thousands more people died of radiation poisoning in the following weeks. The radiation came from black rain, radioactive isotopes that fell from the atmosphere in the first hour after the bombings. The radioactive particles were stained black when they combined with carbon residue from post-blast fires burning on the ground. Despite the devastation of Hiroshima, Emperor Hirohito refused to surrender. On August 9th, another U.S. B-29 bomber dropped a second atomic bomb, this time on Nagasaki. Kokura was the primary target, but cloud cover forced the pilot to drop Fat Man on Nagasaki instead. 40,000 more people died. Although the plutonium bomb was more powerful, surrounding mountains limited the destruction on Nagasaki. By November 1945, over 200,000 Japanese citizens had died as a result of the atomic bombs dropped on Hiroshima and Nagasaki. 90% of all fatalities occurred within 3 weeks after the explosions from immediate vaporization, radiation burns, and blast wounds. Among survivors, severe disfigurement from thermal burns occurred in the form of thick scars called keloids. The scars were both emotionally and physically destructive. In children who survived, delayed growth and brain development were common. In the following years, many survivors of the blast died of leukemia, as well as thyroid, lung, and breast cancer, at much higher rates than expected in the general population. Today, nuclear technology has beneficial uses in the fields of energy, agriculture, and medicine. In 2013, nuclear power reactors supplied 8.5% of U.S. electricity. In South America and Mexico, the Mediterranean fruit fly population was drastically reduced by growing the insects in a lab, sterilizing the eggs with gamma radiation, then releasing sterile males, thereby limiting offspring, resulting in increased harvests. In medicine, radioisotopes are commonly used in diagnostic procedures such as CT and bone scans. Certain brain tumors can be treated with gamma radiation, and some thyroid disorders can be treated with radioactive iodine. Over 1 million cancer patients are treated with radiation therapy each year. However, with North Korea's stand on nuclear weapons, the threat of a nuclear holocaust is still very real.